Now, is this LRU or clock policy always the best thing to do? Well, it is common. Both of them are common, intuitive and simple. They work well for repeated access to popular pages due to temporal locality, as we said. We talked about LRU being costly, but then we said, hey, clock gives you almost the same behavior, and it's cheap. It's a constant time kind of algorithm. And if you like, you can find cases where they differ, and I encourage you to do that exercise for fun. But for the most part, they give you similar behaviors, and so they're considered kind of equivalent. So then let's ask this question: when might they perform poorly, either clock or LRU? And one example that's worth looking at, because we do it in database systems a lot, is repeated scans of big files. So let's go to look at that now. So let's look at LRU under repeated scans. And as we scan this file at the bottom, which we're going to scan over and over, we're going to keep track of how often do we have a hit in the cache. That is to say, we see a page, we get a page request, and we find that page already in the buffer pool. That's called a cache hit. And then how many attempts do we look at? So how many requests did we get from up above? And we're going to look at what our hit rate is as a percentage of the attempts. All right, well, the first request is to page 1, and so that's a miss. It's not a cache hit because the buffer pool is empty. Page 2, same story. Page 3, same story. Page 4, same story. Page 5, and page 6. Okay. And up to now, there was very little we could do. None of these pages was in memory to begin with, so of course, we had 0 cache hits in these first 6 attempts. But now it gets interesting. So now we get to replace pages and see if our replacement policy is doing a good job. So what's the next thing we have to look at? Page 7, right? Okay. Page 7 is going to go into the least recently used frame, which was the one that held page 1. Okay, good. Now we've got 0 cache hits. Page 7 wasn't there either. And we start scanning the file over again. Okay. So on the second scan, the first thing we look at is page 1. And what a shame. We just had page 1 in the buffer pool, but we evicted it. So we're going to have to read it back in. And where do we read it into? Well, that second frame where page 2 was is the least recently used frame. So we'll replace page 2. Uh-oh, look at what we're looking at next. Page 2. What a pity. It was just in the buffer pool, but we kicked it out. So let's bring page 2 into the buffer pool. And what will we replace? Well, the least recently used one was page 3. So now we replace that. We're 0 for 9. And what's the next thing we have to look at? Uh-oh, page 3, which we just replaced. You can see where this is going, right? So we're going to put page 3 where page 4 used to be. We're 0 for 10. And what's the next thing we have to look at? Page 4, right? You can see where this is going. Same thing happens with page 5. We are 0 for 12. And as we keep scanning through the file, we will be 0 for everything if we scan it over and over. This is a worst case scenario. This is pessimal. It's the worst possible thing. And it's often called sequential flooding of the buffer pool. We're reading this file over and over sequentially, flooding out all the pages in the buffer pool, and nothing is recently used. Everything is always equally old, and nothing gets us a cache hit. So Sequential Scan+LRU gives you sequential flooding, a 0% hit rate in the cache. And unfortunately, repeated sequential scan is pretty common in database workloads. We will see it, for example, in the nested loops join that we'll look at later in the class. Well, what might be better than LRU then? Not clock. Clock is going to behave just about exactly like LRU.